Hello, everyone. Thank you, Ali the Cleric. I am Timmy Han, and today I'll talk to you about Presto. Um, so let's get started. I've been working at IBM since for a couple of years, and I've been working on Presto for far longer. So I've been working on Presto since 2018, and I've chaired the technical steering committee since 2022. Um, so I've been involved with Presto for a very long time. So clearly there's something that keeps me involved with Presto, and there's really two big things. The first is that Presto is open source. So the Presto code base is open source, but one thing that's also sometimes missed in open source projects is it's not just code that gets open source, but also um, the way that code gets produced also is open source. So, in addition to your source code just being in a repository that you can fork and build on your own, you can also open up your communication and decision making on you building that software. At Presto, not only is the source code open source, but we try very hard to make sure that the way that the direction that the project moves in is also completely open source. We'll get in, towards the end of the talk, we'll talk about kind of like that open source and practice stuff. But there's lots of forums for you to participate, and if you're interested in coding a distributed database engine, then definitely get involved. It's a great place to be. But in addition to open source, I'm also specifically interested in Presto and the problems that Presto solves. And the reason is that there's just a ton of work. There is way more work that I would like to get done with Presto than I have time for. So there's always something interesting to do and some problem to solve. Those hard problems are really what keep me coming back, year after year, to work on Presto. I really love solving all those problems. Um, and the project hasn't been static. The project has really evolved quite a bit over the years, and I think all the directions that Presto evolves into are very interesting and open up a lot of new use cases. And so this kind of like constant evolution of Presto also keeps me involved with the project and engaged. So today we'll talk about some of these things that have been on my list. Some of them haven't as well, and talk about what we built as a community. Some of the more important things, and we'll also talk about what's next and like what we see for the future. So I think if you were to take a look at the work that we've been doing for the past 1 to 2 years, maybe a little bit more, is a lot of the work that we do is setting ourselves up for a foundational change, or setting ourselves up for the future. So what we're doing is we're working on really core things to help make Presto very, very fast, efficient, and modular. So if you look at the contribution count, is roughly steady. But in terms of the features that we've delivered and the work that we've done, all of this is a lot of it is very foundational in nature, and setting ourselves up for a better future, and for an exciting future. In a minute we'll cover what these features are, but I think like the theme for the past year has really just been just good engineering work. We've solved a lot of I think the core problems of moving to a native engine. We'll talk about that in a second. A lot of the problems for making a very performant query engine. We're starting to see kind of like the fruits of that effort, but it's been a long time coming, and we're starting to finally see this maturing in a way that is very fast and efficient. So there was a lot of major progress this year. I'll talk about all this, but like we've worked on various different layers. We've addressed a lot of the security vulnerabilities that have show up in static scans for Presto. So we've patched up a lot of the security vulnerabilities. We've introduced and hardened ways to load balance Presto clusters so that you can scale them horizontally or geo distribute them. We've worked on upgrading our JDK for better performance and future compatibility. Made a lot of progress on the integration of the native C++ engine into Presto and making sure that it's um, kind of like providing this really great first class experience, and also improved connections and integration. So for example, they are a flight connector, better integration with Iceberg, including the REST catalog, and then also cloud-based deployments as well. So we'll get into all these things. I'll start off with, I mentioned briefly, but prior to the router, I'd just like to mention that we've solved we've probably dozens of security vulnerabilities, especially within the past few months. So if you tried Presto and discovered a static scan, especially like with the connector, give it another try. We've patched up a lot of those vulnerabilities. But moving on, we've made a lot of progress in a component called the Presto router. So what is the Presto router? The Presto router is a load balancer that sits in front of your Presto clusters that allows you to route a query to a different cluster depending on some sort of criteria. A very common use case for this sort of thing is to add more clusters. So if you have a very hot cluster and you've scaled your worker pool, eventually it makes sense to scale your coordinators as well. So basically adding another cluster to help serve the load. That adds a degree of failover, but also is just a very easy approach towards scaling Presto clusters. So the Presto router helps you to easily scale your Presto clusters or even to geo-distribute them if you configure it that way. So this component has existed for a few years, but it's received a lot of attention in the past about 6 months. So we've included support for TLS encryption and authentication, automatic routing between native and Java clusters. We'll get into that a little bit later, but you can use the router to determine if a cluster should be routed to a C++ or Java cluster. This was contributed recently. And also we've added the ability for adding pluggable schedulers so that you can use the Presto router in your own custom infrastructure and have it look at metrics that just aren't known to open source Presto. So like, it could be looking at a Kafka queue or something else. So very, very happy and proud of those updates to the Presto router. We've also made a lot of progress on upgrading the JDK. So Presto is focused on, kind of like C++ clusters, but we still use the Java coordinator, and we still use Java workers as well. So, like we're, while we're migrating off of Java, for the worker pool, like we're upgrading the JDK for both the coordinator and Java nodes to improve performance and to solve vulnerabilities. So, some of the milestones that we hit this year was we were able to build on JDK 17. Pretty soon we will be updating the default to be JDK 17 once large users complete their testing and are comfortable with it. And then also, once this gets merged, this should open up upgrades to connectors and unlocking new connectors that might use libraries which are JDK 17 only. So this is a long time coming, but very happy that we were able to accomplish this year, and we should be able to achieve a much tighter cadence on JDK upgrades for the upcoming years, now that we've kind of gotten over the hump from 8 to 17. And by the way, there's a very large performance boost by upgrading the JDK. So that's also another very important benefit for the upgrade. But the JDK upgrade won't get you to native performance. Like the we spent a lot of time just really rethinking the architecture for the eval layer for Presto. And so, like this is essentially our future. We put a lot of effort into production hardening C++ clusters in the past year, and we've added several new improvements. So, firstly, we've improved TPCDS latency on certain queries by a large factor, using like improved window function pushdown. There is we're developing a native integration into connectors and functions. We'll get into that in later slides. We now have a Helm chart for so that you can easily deploy and test out native clusters, and we have Iceberg read support so that you can use C++ clusters with your Iceberg cluster, not just the Hive cluster. And we should be adding support for additional table formats in the future. But in addition to the performance enhancements and kind of like the hardening on C++, we're also starting to work towards making C++ the default. So we don't want to be in the situation forever where we have both a Java worker and a C++ worker. Eventually, we want to move to only C++ workers. The reason for this is there's just less to develop, and we think that it'll be a superior experience. So, like from a development standpoint, we want to make the switch so that we don't have to support two different evaluation layers. And just from a usability standpoint, we want to eliminate the confusion and in the future have only one choice. But as you can imagine, there's a lot of work to get to that stage, and so a lot of that work is bringing together some of the functionality that doesn't quite work on C++ clusters and bringing them to Java. So we did make a lot of progress on that in the past year. So we brought some additional consistency in the types that are supported between C++, the C++ eval, and Java. We now have functions and UDF support, which are validated in the coordinator, so that you can write actually a C++ function and have it be executed in the workers and be validated by the coordinator and registered properly. So we now have like full UDF support, like we've had in Java, for a very long time. And we have a plan checker that ensures that the query will run correctly when it is scheduled. And we're starting to use this for routing inside of the Presto router. I believe I mentioned that earlier, but we're starting to use this for making routing decisions on whether or not a query should be run in a C++ cluster or a Java cluster. So that, we've made a lot of progress. We're definitely not done, but, I think, we've made, a pretty sizable chunk on, kind of like the open issues that are preventing us from making C++ the default. We'll be creating an RFC on, how we see the switch to C++ as the default, what that means for users, and then we'll also be adding more features to plug the gap between C++ and Java. So definitely stay tuned for all of that. But in addition to that, we've also added support for the Aeroflight. So let me get into this a little bit. Aero, as you might know, is a data format that specifies a common format for how to share analytical data between two different systems in memory. So Aero has been gaining a lot of momentum as just a sort of universal data interchange format for things that are not persisted, for example, Parquet. And people are starting to create services and other components that also speak in terms of Aero. So Presto can now actually, connect to these services as a connector using the new Aeroflight connector. So these connect to Aeroflight services. There is support for both Java and C++ deployments. Of course, the Aeroflight service can be in whatever language you need it to be. It could be in Python or Rust or or whatever. There doesn't have to be a any type of language restriction as long as it supports Arrow. And in C++ clusters, you get this added benefit that there's zero copy and very fast data interchange. And in the past year, we've added support for TLS and authentication on top of that. So like now you can use Aeroflight to connect to Arrow services. But I think what's really interesting are what we're going to build next on top of that. The first is adding support for Aeroflight SQL. So like Aeroflight SQL is a standard that uses Aeroflight to connect to databases. So certain databases already speak in terms of Aeroflight SQL. Off the top of my head, Postgres is a good one, and I believe DuckDB as well. And so this should open up more connection opportunities with other external databases. But on top of that, also, we plan to add a shim that allows you to port a Java-based connector and expose that as an Aeroflight service. This would allow you to port a Java-based connector so that you can try out C++, but port over your connector in case you have a connector that's written in the Java SPI. So we believe that this is an important first step on allowing more connector support in our C++ clusters. Obviously, there's a lot more work to do in this area, but we believe that this is a very important next step. So I'm very excited to share that. We also continue to make a lot of improvements to the Iceberg connector. Iceberg is a table format that largely replaces Hive and solves a lot of the limitations with Hive, including better engine interoperability, better file pruning capabilities, and support for compaction and time travel, and a lot of the things that you've only seen recently with the addition of modern table formats. We continue to see a lot of momentum around Iceberg. So we've put a lot of effort into making Iceberg as good as possible. So one of the most important milestones we had was really performance parity with the Hive connector. So this includes extensive end-to-end caching, better filter pushdown, and file pruning capabilities. So with this, there's the Hive connector has traditionally had a better performance profile due to just the amount of development that it's received, but we've been able to close that gap so that performance shouldn't be a factor when choosing between Iceberg and Hive, at least for Presto. So very happy to share that performance improvement. We have also added and improved our support for the REST catalog. So we do support the REST catalog, but not only that, we also support nested namespaces within the REST catalog and have support for Unity and Polaris catalogs. So the REST catalog is growing to be an important convergence point for the Iceberg community, and support for Unity and Polaris in particular are growing to be very important. And we've also added support for Iceberg Read so that you can have a native cluster and use it against your Iceberg data. So that's also something that we're very excited about. So I've shared I think a lot of important milestones. I'll go over just a few things on stuff that we're working on and stuff that we're kind of thinking about just to see what the roadmap is like. One project that I think will be really important is thrift migration. So migrating the internal protocol of Presto to Thrift. This will improve the coordinator scalability and performance quite a bit, especially when it's under a lot of load. So we're definitely excited to see that enhancement. And as part of doing that work, it's also going to lay some of the groundwork for better, even more connector support within C++ clusters. We are also going to have better native integration for connectors and functions. So We have the Aeroflight connector, which will allow you to migrate some connectors, but we'll be adding even more support for connectors, including in-process connectors. So like writing your own connector inside of a C++ cluster, and then adding it as a shared library, as you can do with Presto today. We are planning a lot of work on our optimizer because we have seen tremendous improvements at the eval layer, but we haven't prioritized as much work in the optimizer. And so there's a lot of performance wins to be had by focusing on the optimizer. And we think that this will, further increase the performance gap that we see between Presto and its peers. So the optimizer, I think, will be an important area of future investment, especially as we've kind of like collected a lot of the performance and performance gains that we've seen just by switching to native. We're also going to be adding support for the merge operator. So like this will unblock use cases like change data capture tables and just allow for more flexible ETL. So that'll be very exciting. Looking a little bit further ahead, there's a lot of, I think, really interesting features that are coming down the pipe that just point to Presto's just focus on extensibility. The first is table valued functions. We'll be adding support for first class table valued functions so that you can add functions that basically operate as a table. So there's a lot of support for this in query engines, and we'll be adding support for this as well, both in process and out of process table valued functions. We are exploring support for GPUs with CUDA. So this is experimental, but like we've seen good performance for queries that do support it. So definitely keep an eye on developments related to GPU support. This is of course possible because of our integration with vlocks, and so it's possible to very easily integrate, or much more easily integrate with GPU libraries and leverage that support. We're adding geospatial support in C++, so this will kind of like close one important gap that we have with Java, where types and functions and operators that operate over spatial types should now be supported. I just mentioned, but like we will be working on our cost-based optimizer, and then also, but in particular, we want to add support for dynamic filtering, both at the optimizer level, and then also using the information gathered from dynamic filtering for partition pruning. So in particular for Iceberg tables, pushing down the dynamic filters into the scan planning so that we can eliminate files and reduce the amount of work there. So taking a look at the bigger picture, what are we working towards? I think it can be summed up in just a couple of different ways. The first is interoperability. So we're focusing a lot on Iceberg with REST, Aeroflight. We believe that interoperability and the ecosystem is very important. So we're continuing to invest in, in connectivity. Through our investment in, migration to C++, we've developed a very modular and flexible architecture, which shows that, which you can see with GPU support, pluggable types and functions and connectors. So we're continuing to put a lot of effort into modularity, and like we can see that with our move to C++. And Presto in general, is just becoming more cheaper to run. So overall, like we're developing a modular, flexible system that's just very, very performant. As I mentioned, like the past year has been a lot of foundational level changes. These will start to come to the picture this year and next year, and we'll start to see a lot of the benefits becoming visible in the open source product. So very proud of the progress that we've made, and I'm very excited for it to show up in Presto itself. So with that, I just want to mention that an open source project, needs people to, help it work. And so, like, as I mentioned, Presto is open not just in the code, but also in how it operates. Not all open source projects are like that. And so, we really are looking out for anyone who likes to participate. There's a lot of different ways to participate. You can join the Slack channel, you can contribute code or open GitHub issues. If you go to our webpage, prestodb.io, you'll find working groups. You can self-subscribe and just join in on any of these working groups to see us design and think, talk about the future of Presto, and or you can sign up to our mailing list to receive updates and important notifications. So there's lots of different ways to get involved. If you're just figuring out where to get started, just join Slack and say hello, and we can talk to you and see what you'd like to use Presto for. So with that, thanks for coming to PrestoCon. I hope that you can see, like me, like we're working on big stuff, and to me it's like super exciting, and I'm happy that we got a big crowd here to talk about it and explore Presto's future together. So thanks for coming, and enjoy all the talks.